Okay, exercise 4. In the figure below, triangle ABD is congruent to triangle CDB. The measure of angle A is 2x plus 14, the measure of angle C is 3x minus 15, and the measure of angle DBA is 49. So, what's the measure of angle BDA? Okay, so to solve this, we know that this triangle is congruent. These triangles are congruent. So right off the bat, let's find x. So we know that 2x plus 14 is going to be equal to 3x minus 15. So we can already just throw this here and throw this here. So 15 plus 14 is equal to 3x minus 2x here. So 15 plus 14 is 29, and 3x minus 2x is x. So here we already have x. Now let's find out angle A. My goal behind this is that if we find this and this, we can subtract them from 180 and find angle BDA. Okay, so 229 plus 14. So that's going to be 58 plus 14, because this would be 60 minus 2, because it's minus 1 times 2. And then with this, let me just do this to be sure. 50, oh, this doesn't solve anything. 58 plus 14, this and this is 12. This is 6, but plus 1, 72. Okay, so we know that angle A is 72. Can you see it there? Yes, you can. So 72 plus 49, that's gonna be 11. 9 plus 2 is 11. 4 plus 7 is also 11, but it's gonna be 12. So 121. Okay, so now we can go to find the angle BDA. So we know that there are 180 degrees inside of a triangle, so 180 degrees minus 121 degrees. You don't need to put the degrees, but I like to put them in the last step. So pass this to this side. So this is 10 minus 1, it's 9. 7 minus 2, it's 5. 1 minus 1, 0. So now we know that angle BDA, the measure of angle, let me write this formally. The measure of angle BDA is going to be equal to, can you see there? Yes, you can. Equal to 59 degrees. Okay, exercise 4. Okay, so exercise 7. We gotta determine if the triangles are congruent. If they are, we gotta write the triangle congruent statements and name the postulate that tells us why they are congruent. So I have to do 7-4 and 7-9. So let's start 7-4. Here we have triangles JMK and LKM, because of the order, right? And right off the bat, we can see that there are two congruent angles and one side that is shared. As we already know, a segment is always going to be congruent to itself. So we have angle, side, angle. So angle, side, angle is a theorem that can be used. So we know that this triangle is congruent by ASA, and that, let's write the congruent statement now. So triangle JKM is going to be congruent to triangle L. So we're gonna go here because we went here. LMK. So it's kind of bad because I'm looking at the camera, but this is the congruent statement, and this is the postulate that I used, theorem that I used. Okay, so now, this is moving a bit. So now, 7-9. So we have triangles VUT and RQP. So we have two congruent sides. However, we don't have anything else. There are no congruent angles, and the sides aren't touching, so there are no segments congruent to themselves. So unfortunately, there is not enough information. Okay, so exercise 9, we have to find each error and make corrections. So we have 9A and 9B. So on 9a, it says that triangle DEF is congruent to triangle IGH. However, I drew the triangles here. If you look at them, there is no H. So the name of the second triangle is wrong because there's no vertex H on the exercise. Okay, so straight up, let's do 9b. So the triangles are congruent by HL, which is hypotenuse leg. And this is also false because, as we can see, sorry for the curved drawings, these are supposed to be congruent, but yeah, they are not congruent by HL because the hypotenuse and the hypotenuse are not shown to be congruent. So we can't just determine that. They're actually congruent by SAS because they have side, angle, side, side, angle, side. So yeah, that's it. I didn't write my answers because they would be long and they kind of long to write because I have a slow handwriting. So I hope this isn't too much editing, but bam, it's on the screen now. Okay. Okay, so this one, it looks like it's already solved, so there's a lot to unpack. Exercise 11, we have this situation here, and we have to fill in the statements and reasons. So yeah, let's do this. So we have two triangles here, HGF and KGL, right? And it's given that segment GF is congruent to segment GL, so GF and GL. And it's also given that segment FH is congruent to segment LK. So these are parallel lines. We also know, so we have to prove that triangle FGH is congruent to triangle LGK. So here the statements. Statement 1 is this one. Segment GF is congruent to segment GL. This one's a given. So second one, segment FH is parallel to segment LK. This one is also a given. Let me mark the ones that we don't have. So third one, angle F is congruent to angle L. So these and this. So we know that that's true because if these are parallel, we can use the alternate interior angles theorem. Okay, so 4, it's this and this. The reason it says vertical angles theorem, but we don't know what it is. But it's really easy because the only ones that could be vertical angles are these ones. So it would be angle HGF is congruent to angle KGL. KGL, HGF. That's proven by vertical angles theorem. And last but not least, we have the last proof. So triangle FGH is congruent to triangle LGK. And that can be proven by ASA, because we know that they have one angle in common, one side in common, and the one side that's congruent, and another angle that's congruent. So angle, side, angle. So ASA. That's it.